feel awkward on that on.
Because it'll be start tracking.
At some point, you're gonna realize that. I do it before. Or you don't have to give the grade.
Okay, let's see what sort of results you got. I put a sketch at least of the graph that you would have ended up with. Again, asymptotes, label those with your dotted lines. Okay, so we had a vertical asymptote at x equals 4. And that was because that made it undefined down here. We had a horizontal asymptote y equals 1, and that's because in the long run, that x over x is going to win out. Okay, so hopefully we're getting fairly comfortable with those two things. X-intercept. Who can tell me, first of all, what was the x-intercept? And then we can think about how we found it. So it was negative 40. Say it again, I'm sorry.
Negative 40. Negative 40.
Okay, so the x-intercept was negative 40. How did you get that?
I graphed it on that.
Say it again, I'm sorry.
I graphed it on that.
Okay, so this was a pretty nice graph where it was nice neat x-intercept. Okay, so that was fine. Other ways, though, we can get the x-intercept? Yeah, try to solve the equation when y is equal to 0. Well, if we think about it, if I have a fraction and it ends up being 0, really the only way that can happen is if the numerator were equal to 0. And that's where the negative 4 would come in. What about y-intercept? Where would I put the 0 this time? Yeah, correct. So Jaden, what did you get when you did put it in? Yeah. Okay, so remember those rules still hold true. Y-intercept is x equals 0. X-intercept is when y equals 0. Okay, domain here. What did this group, what did you guys decide your domain was?
All reals except.
Okay, so all reals except we had that one value of positive 4 because that was our undefined value. All right, what about range? This group get your range?
All reals except for 1.
Right, all reals except for 1. If we can, if we think about it, we said in the long run it gets close to x over x, which is really close to 1, but we'd still have just a little bit above it and just a little bit below it, so that's why we don't actually equal that value of 1. All right, so hopefully we're feeling pretty good about those. What about that last question, though? I asked you to try to rewrite the equation. We're going to create a graph that would have a hole in it instead of having these asymptotes in there. So we had this pop up the other day. How can we create that situation, Zach?
Our group, we did y is equal to, well, parentheses, x plus 4 divided by parentheses, x plus 4.
Okay, so let's say I did that. We know it's going to basically simplify down to 1, right? So we kind of like the other day where we had that horizontal line at 1. Where would I have the hole at, though?
4.
Close.
Negative 4, sorry.
Negative 4, yeah. So, yeah, these two would cancel or they would simplify down to 1. But we still have that one excluded value, that one value that doesn't work. Did anybody rewrite it a different one? What did you guys do?
Y is equal to x minus 4 over.
Okay, so what would be the hole in your graph?
Positive 4.
Positive 4. Okay, so if we have that happen, and that as we get more and more equations kind of like this, we'll find out, okay, there is some times where it's going to simplify down to 1, which may not give me asymptotes, it may give me undefined values or holes in the graph. All right, so that was one of the ideas that we talked about on Wednesday. Today, what I want to do is kind of follow up with the other thing we were doing on Wednesday. So one of the things